Hey, what's up everybody? Ed the Pond Professor here, coming to you from my office today. So you know what that means. It is time for a design discussion. Today's going to be a little bit unique. We're going to be talking about the actual roof of the facility that I'm actually working in right now, which is known as Aqualand. The reason we're doing that is we kind of have a unique opportunity because Aqualand is a environmentally conscious facility. We have a silver LEED certification. So if you're not familiar with the LEED certification program, it stands for Leadership in Energy and Environmental Design. So that means you're taking a lot of different things into consideration throughout not only the construction process, but also in the overall operation of the facility to make sure that we're utilizing resources efficiently and effectively to get the most out of everything, as well as cut back on greenhouse gases and things like that, and managing stormwater. And that's really what I want to talk to you today about, because you've heard me talk about stormwater stuff before. Super important. It's near and dear to my heart, and that's because I'm an outdoor person. I have a lot of activities that I do on a regular basis that are aquatic based, and a lot of those unfortunately have taken a beating over the years, and that's just because of a lot of different pressures that have been put on all those resources because of the world that we currently live in. So that's really what I want to talk to you today about. So here's a picture of Aqualand, and you can see this is shortly after it was actually built. You can see our signature water feature in the front, which has changed dramatically because the trees and things now in front of these are massive. So you would not get the same view of this anymore. All these mulch areas and things like that that are visible are totally taken up because they've filled in with plant material, water lilies have taken off, etc. So it has changed dramatically over the course. This feature was built back in 2008, so that water feature is 14 years old. What I'm talking to you today about though is the stormwater management plan and the roof. So because our facility is 14 years old, there is new technology. When we built our facility here, it was state of the art. It's still a phenomenal place. If you haven't been here, you definitely have to check it out. If you're anywhere near Chicago, please come on by because you'll be blown away by all the cool stuff that we have here. But like I said, technology's changed a little bit. When we designed this roof, we wanted to have a green roof that had a living Illinois prairie on the roof. So that was kind of a cutting edge technology. And at the time of construction, this was one of the largest green roofs in North America. So when we talk about green roofs, the big question is, why would we invest in this? Why would we spend the money to have plants living on the roof? So I'm going to tell you a little bit more about this. So right here, I have a couple pictures. The one on the left is Chicago. I took this picture not that long ago, flying it back into O'Hare Airport. And as you can see, into the horizon is city lights. So the sprawl that happens around a lot of our urbanized areas is huge. So that urban sprawl has made an impact on the local infrastructure, the ecosystem, the hydrology, you name it. There's a whole huge ripple effect that goes out in all directions. Now the picture on the right is kind of on the outskirts of Chicago, and it is a native Illinois prairie. So this is what Illinois would have looked like a couple hundred years ago before people arrived here. So it would have been vast prairies, we would have some tree areas, savannas and stuff like that. The reason I want to talk about that is we've changed hydrology dramatically. So by getting rid of all of that beautiful soil from many years of prairie plants growing in it is like a huge sponge. So when it rains, that rainwater gets soaked in and it slowly percolates back down into the groundwater system and it replenishes our aquifers. But now what is actually happening, and here's a daytime view of Chicago, and it shows you a little bit more in detail here what's actually happening. So as you can see when you look at this, it's concrete, it's steel, it's asphalt. So a lot of those surfaces that normally would have been green and would have been on top of beautiful topsoil has been capped off. There are buildings, there are structures. Now we can't get away from this. It's impossible. We need a place to live. The population continues to grow, but we need to be smarter on how we live in these locations. And we have technology now that we could actually offset some of the issues that we're seeing from this urbanization process that's actually occurring around the world. What I want to talk about is how we could actually fix that. And first, I want to show you a little bit about the scale of what we're actually talking about here. So when we talk about urban runoff, 1 inch of rain, not a lot of rain, right? Here in Chicago, we average 40-ish inches of precipitation per year. I'm just going to take one of those inches right now. So 1 inch of rain, if it falls on an acre of land, which is about the size of a football field, is going to be 27,000 gallons of water. Sounds like quite a bit of water, right? Now you start to scale it out a little bit. So look at the Chicagoland area, and this is not even the size of Chicago, but I just took a 20 mile by 50 mile section. It's gonna generate 17.3 billion gallons of water. That picture over on the right is showing Willis Tower. That is one of the largest buildings in the world. It was actually the #1 largest for quite a long time, tallest, etc. But now there are bigger ones out there, so I'm gonna reference that building. 17.3 billion gallons of water will fill that building with water 43 times. I mean, that's just a crazy, crazy, crazy volume of water. And that's just 1 inch of rain. We get bigger rain events. Now, what I'm talking about with this is when we're talking about permeability, you are going to lose some water into the wetting of the surfaces. You're going to have some green spaces where water is going to soak down into subsoils. But in heavily urbanized areas, this is actually what you're getting. You have tons of roof space, lots of parking lots, lots of roadways, and even the turf areas. Those are considered semi-permeable, and that's because we have a compacted clay layer that is just under our typical turf, and then turf grass itself has a very tight-knit root structure. So it actually, over time, you have to aerate it and things like that, and if you don't follow along with those processes, it inhibits water flow from going down into subsoil. And I can talk about this from experience because as a pond builder, I routinely would come in and I will strip away the turf with a sod cutter before we start construction, and I could go out after a thunderstorm, the day after a thunderstorm, strip away the topsoil, and if I go down about 4 to 6 inches, the clay underneath is actually dry. And that's because all of our properties have a slight pitch to them. Most homes do not have a perfectly level yard. It's usually pitching away from the home because you don't want water going back towards the foundation to cause any water issues. So it's gonna have a slight pitch to it. So when water falls on it, and if you have a tightly knit root structure, that water's gonna flow away. And that's if it's just turf grass. Most of the time we have patios, we have walkways, we have roof structures, we have hard surfaces all around us everywhere. That water flows off instantaneously with zero permeability. So that means we have a lot of runoff. So what are the issues with it? So this slide here I think does a really good job of explaining that. Non-point source pollution. So that means we're getting pollutants from a ton of different areas. We can't pinpoint one specific area, and that's because it's very diffused from a lot of different places. Rainwater, as I've told you before, is known as the universal solvent. More things will dissolve in it than any other compound on planet Earth. So that is a good and a bad for that water molecule. Good for us because it cleanses the earth. Bad for the water systems because all it does is makes that stuff soluble, and then it takes it off into our water systems. So as you can see here, you're gonna get all types of stuff. Everything from animal waste, you're gonna have fertilizers and phosphates and things like that coming from natural areas. You're going to have heavy metals coming in. You're gonna have all types of litter. You're gonna have hydrocarbons coming in from a wide variety of different areas, and all that stuff mixes together and it kind of creates this toxic stew of stuff. Now that stuff has to be managed in some way. Here in Chicago, we have a combined sewer system. So a combined sewer system means our stormwater and our sanitary sewer from our toilets and sinks and things like that all gets combined together. The problem is because of the heavy precipitation that I just talked to you about, when all of that water comes together, it's like a tidal wave of water going to the wastewater treatment plant. They cannot handle it fast enough. Currently what Chicago did was they created a deep tunnel project and stormwater management practices to store water in these massive reservoirs until it can be cleaned. Still not big enough. So what's happening, sometimes it's known as a combined sewer overflow. So that means some of this water has to be discharged directly into our river systems untreated. And that's because if they don't just open up the floodgates, literally open the floodgates, what happens is we have flooding upstream. downstream. So what happens is all that stuff goes downstream, and our wastewater here in the Chicago suburbs is going to go all the way to the Gulf of Mexico. It's kind of counterintuitive. If you've ever been to Chicago, you realize we are right on the shore of Lake Michigan, but most of our stormwater, well, other than a very small fraction right along the lake, goes all the way to the Gulf of Mexico, 1,000+ miles away. And in that time, it's going to pick up more and more stuff as it's going on its journey down. One of those problems is actually these areas that we're seeing our streams being heavily eroded, and that's because of all of that water getting channeled into one specific place that normally would not naturally happen. So in nature, you're gonna have water falling into those deep soils like I was talking about. You're gonna have pockets, you're gonna have little fens, and you're gonna have bogs, and you're gonna have natural areas and marshes and things like that that could actually absorb some of that storm water, and it mitigates it. So instead of having these peak flows, we actually have a more even flow rate going through our river systems. Again, that's part of a different discussion. So these are some of the issues that we're seeing. So we're seeing pollutants, we're seeing degradation of our river systems, and all of that stuff, like I said, is going down to the Gulf of Mexico, which is causing a huge dead zone. So this is a serious, serious issue. Every single summer, we get these dead zones that pop up. This actually map right here is from 2021, so just last year. This was over 6,000 square miles of a dead zone in the Gulf of Mexico because of stormwater runoff coming down the Mississippi, discharging into the Gulf of Mexico. When I talk about a dead zone, it's literally killing everything. Nothing can survive because of this toxic mixture of stuff that is coming down the river system, and it enters the Gulf, which is actually an important food supply for us. I mean, there's all types of shellfish and fish that are actually harvested from these areas, as well as all of the tourism money that is generated by all of these communities. And if you look at this map, I mean, you could see this is where the Mississippi River kind of comes in. It kind of winds its way through, and it's going to split off in multiple areas. But we're going from Louisiana, this is all the way to Texas. So it's a massive, massive area that is being impacted every single year. The reason I'm bringing this up is not to scare everybody, but it's to raise an awareness about this stuff, because like I said, we have the ability to fix some of these things. Some of those strategies, you've heard me talk about them before. It's rainwater capture, where we could actually do rainwater capture by, and you can see precipitation coming down over here. This is permeable pavement, which has specially designed joints that allows the water to flow down through, and it can be captured into an underground reservoir. Now that water can be utilized on site for irrigation, for water features, for outdoor activities. So instead of pushing it downstream, we're actually holding it on site as an asset versus pushing it away as a liability. Here's one of those projects that I've worked on. This is Phipps Conservatory. I did a really cool vlog on this not that long ago. I was actually here 1 year ago looking at this, and this is an incredible, incredible project. We have all types of stormwater management practices being utilized on this particular location. The reason I wanted to show this is because they ended up doing a green roof on top of this facility. And that's really what I'm talking about here, is the green roof construction. So here is the top of Aqualand. So our massive roof system is almost 200,000 square feet of roof. So we have this huge roof system, but as you can see here, we have a large section of it. Actually, the majority of it is actually a green living roof. This was designed and built to hold native Illinois plants. We are now going to upgrade it because some of these plants are struggling. And that's because we only have 6 inches of soil on the roof. So what we're going to do now is we're going to rip this stuff apart. We're going to redo the irrigation. We're going to amend the soil because the soil has become depleted over the past, the roof was built in 2006. So in the past 16 years. So we are going to rejuvenate the soil, do new irrigation, and come in with a new plant mixture using a sedum mixture, which can handle the harsh conditions that are found on top of a roof. You can actually see me standing on this corner. You can see some of the irrigation that's actually exposed over here. And then this corner gets a high wind load. So that is going to be fixed. We're also coming in and we are going to do some safety protocols, because as you can see right now, I'm just literally standing on top of that roof and I'm about 40 feet above the parking lot. So there's going to be a safety system going around the perimeter. So if we're up there doing any work, we're gonna be safe. What does this actually look like? What is the process? So here's the actual green roof up here. Then we have the roof deck, which is right below it in insulation. We have purlins that are holding everything up. We have these huge I-beams that kind of come across. This is transferring that weighted load down to the subsoil. Down at the bottom, it's going to go into a large concrete base, which is going to handle that high load. The reason I want to talk about this, when you're talking about green construction, this is designed in right from the get-go. You can't just go in and throw dirt on top of your roof. The roof would fail. And that's because the weight of the soil, the weight of the plant material on top of it, what happens when it's full of water. So that saturated soil is going to hold not only the soil itself, but when it's wet, it's going to be heavier. So all of those combined loads have to be calculated. The beams, the loads, the columns, the concrete footings, all of that has to transfer that weight down into the subsoil, otherwise you're going to have a failure. So what does the actual cross section of the green roof look like? You could see those layers I was just talking about. Structural support, we have our roofing membranes, we have a root barrier, then we have our insulation board, and then on top of that insulation board is a very important piece. It's known as a drainage board. So what that's going to do is it's going to allow any excess water that goes down through the soil before it hits the roof. It's going to give it an open area, kind of an air gap in between the bottom of the soil and the top of the roof. This is going to allow that excess water to drain away where it's not going to cause problems. You don't want pools and puddles of water sitting on top of a roof. It's not the way it's actually designed. So we want to try to move that away. So the goal is to have all these different layers in place. Now we have all of this stuff. We don't have to change any of the structural components, the drainage board. What we're doing though is we're going to redistribute the soil. Over time, the soil has moved from wind action, from rain action. We've done measurements. We're going to redistribute it to give even distribution of that soil. So we have an average of 6 inches. That's going to allow us the optimal growing medium that we're looking for. Then it's going to be planted with a variety of sedums, which are going to be very, very resilient. They're going to be heat tolerant. They don't require as much water as other plantings, but they're going to protect that barrier, and it's going to get rid of the heat island effect. It's going to cut back on stormwater. It's going to absorb carbon dioxide. You can see all these different things that are actually occurring once you do one of these strategies. Not only that, but this is going to become home to a wide variety of pollinators and beneficial insects and birds and different things like that that'll use the top of our roof for nesting and for food. So I apologize for going along with this, but I thought it was something that's very, very important to me from an understanding perspective, and I hope you walk away with some new knowledge and a new appreciation for that green infrastructure that is actually starting to pop up all around us. So if you see an opportunity to do something, please do it, take care of it, because you're only making the world better for all of us. All right, thanks for joining in, and I will see you next time once we start doing the construction and the renovation on our incredible building. All right, everybody, see you soon.